typically we've been talking about planes where the 3 points are all on where we have a plane that's like the XY plane or the YZ plane or the Z X plane. But what happens when we take a random 3 points? Well, one of the things we learned in geometry is that any random 3 points you can create a triangle from, and that triangle lies in a plane. That plane doesn't necessarily have to be the XY, XZ, or YZ planes, and those are called coplanar points. So recall that 2 points determine a line, 3 points determine a plane. So if I give you 3 points in 3 dimensions, you should be able to tell me the plane. So that's what we're going to learn about today. We want to write the equation of a plane through 3 random points. The process that we're going to follow is first, we're going to use any 2 pairs of points to write adjacent vectors. So if we have 3 points, you're usually not going to have them all drawn out for you, but you can find this vector and this vector. So I'll call those vectors u and v. Then we find the cross product, u crossed with v. And one of the properties of cross product is it gives us a perpendicular vector, a normal vector. Then we can use that normal vector and any random point to write the equation using our general form. Sorry, standard form. So let's do that. Let's pick 2 points. We're going to use these 2 to create a vector u, and that vector is going to be final minus initial. So 5 minus 2 is 3. 1 minus 6 is negative 5. And negative 4 minus 10 is, minus negative 10 is positive 6. Yes. Now I need to pick another 2 to make v. And it really doesn't matter which two I use. So final minus initial gives us 3. And then 5 minus 1 is 4. 0 minus negative 4 is 4. So here are our 2 vectors. These happen to be looking like this, but the point is that they're in the same plane, so their cross product is going to be perpendicular to that plane. So let's find the cross product of those. So the vector u crossed with vector v is I, j, k. 3, negative 5, 6, 3, 4, 4. So that gives us negative 5, 6, 4, 4 minus 3, 6, 3, 4 plus 3, negative 5, 3, 4. These turn into negative 20 minus 24. 12 minus 18. 12 minus negative 15. Now this becomes negative 44 minus negative 6, so positive 6. And that will be plus 27 k hat. So this is a normal vector, and it's through one of these random points. So I'm going to write an equation using this vector, so I know that because this is a normal vector, I can use those as the coefficients. And then I'm going to do x minus x1, y minus y1, z minus z1. So x minus y minus z minus. And I can use any of these points. I'm going to just use the first one. 2, 6, negative 10. 2, 6, negative 10, which makes that plus 10. So this is the equation of a line of a plane that goes through those 3 points. Once again, we found 2 vectors. We took their cross product. and then use those as the coefficients with a point as x1, y1, z1. So what plane contains these 3 points? So let's pick 2 vectors to make, or 2 points to make a vector. So this would be -3, +4, +1. This time I'm going to change it up. I'm going to use this one and this one in order to create that vector. That's part of that vector, or that point. So 7 to 12 is 5. 0 to -4 is -4. -4 to -8 is -4. It doesn't matter which one we use as long as we use two different pairs of points. So it also doesn't matter what order we take the cross product in. We'll get a different answer, but there are multiple equations for the same plane. Now we take this cross product, I, j, k. Bell might ring and interrupt me. 5, -4, -4, -3, 4, 1. This is -4, -4, -3, 1, minus 5, -4, -3, 1, plus 5, -4, -3, 4. Continue, -4 minus -12. Oh, sorry, +12. Minus 5 minus 12. 20 minus 12. Did I set these all up right? Oh. You see here for this one, this should have been -4, -4, 4, and 1. So here was an error. That should have been 4. I believe the rest is correct. So yeah, this should be -16. -4 minus -16 is 12i. This is -7, so +7 j hat and 8 k hat. So those are our coefficients. 12, 7, 8. They're all adding up to 0 with our parentheses x minus, y minus, z minus, and now I can pick any random point. Let's use this one. 7, 0, and -4. 7, 0, and -4. So our final answer, 12 times x minus 7 plus 7y, because y minus 0 just becomes 7y, and 8 times z plus 4 equals 0. So that is how we write the equation of a plane through 3 points.